Okay, good evening. This is, good morning already. It's July 31, 2023. Okay, my topic for this morning will be a long video lecture on college algebra, and this will now be lesson number 20. Okay, let's proceed. This is Professor David J. De Los Reyes. Okay, our topic for this morning will be a continuation of the long video format discussion on college algebra. This is now lesson number 20. And this is factoring. Okay, this is part 2. Because factorization was a, what I call this, a long topic. There are so many subtopics, right? It's around maybe 12 topics under special products and factoring. So I will try to lecture it in a sequence, so it's by force, okay? So the last time around, for lesson number 19, still under factoring, we are done with the product of two binomials, okay? Square of a binomial, product of the sum and difference, and the cube of a binomial. Actually, the first four topics from lesson number 19, we don't have to memorize it, okay? As long as you know how to expand or use the distributive law, okay, we could perform those factorization. Except maybe for the cube of a binomial, because a cube of a binomial is a little bit longer. Yeah? But later on, when we go to the so-called concept of binomial theorem, this cube of a binomial will be an easy one. But for the meantime, since we are only on the so-called factorization, the factorization of a cube of a binomial, that is a plus b to the third power and a minus b to the third power, there are actually four terms. Okay? Later on, when we go to the binomial theorem, I will try to give you the secret on how to memorize this one without any hardship. Okay, let's proceed for lesson number 20. For lesson number 20, there are four subtopics also. It's still, we are under factorization, so this is part 2. The lesson number 19 was part 1. Okay, lesson number 1 for factorization under lesson number 20. That is factoring polynomials with common factors. Okay? You don't have to memorize this. It is just that the method of factorization is by factorization by using common factor. Okay, let's try to... what is a polynomial? Polynomial is an expression that contains many terms. So if it contains 3 terms and there are common factors, and on how to factor out, it should be by common factor. Okay, let's bring out an example so we could visualize the importance of the factoring by using common factors. Example number 1. Factor, we are given a polynomial here, 3 terms. 24x squared y cubed plus 18x squared y plus 45xy. And the problem is asking that we should factor out this one by using common factors. I will give you the proper concept on how to factor out this one, okay? So in all your life under college algebra, you will be using this one if you want to follow, okay? The proper factoring of this will be something like this. Try to bring out the first term, 24x squared y cubed, right? So try to multiply, the operation is multiplication. So try to subdivide the given term into so many factors, into so many prime factors. 24 can be written as the product of 8 by 3, and x squared can be written as the product of x and x, and y cubed can be written as the product of y times y times y. So laws of exponent, y multiplied by itself 3 times is actually y cubed, and x multiplied by itself 2 times is actually x squared, and 8 times 3 is actually 24. So this term here can be written as this. Okay? For the second term, 18x squared y, 18 can be written as the product of 6. The operation here is multiplication, right? 6 times 3. And x squared can be written as the product of x and x. And y, it will just be simply itself, times 1, or just simply y. Okay? For the third term, it got a coefficient 45 and the variable terms are xy. So 45 can be written as 45 is 3 times 3 times 5. Okay? We are thinking of a number which is similar to the first two coefficients. So 45 can be written as the product of 9 times 5, but 9 can still be written as the product of 3 and 3 times 5. X can be written as just simply x, and y just be simply y. Okay? So if we now try to bring out the common factor, it is just something like this. I just invented this one myself, okay? Even though you try to read the concept on how the book explain common factor, it is not like this. So for me, I got a long experience teaching, so I will be showing this concept. Okay? We'll try to check the common factors for all the three terms. We got a 3 on the first one, right? We got a 3 on the second one. And we got a 3 on the third one. How about this x? We got an x on the first one. We got an x on the second one. We got an x on the third one, right? How about for another x? No more. No more. Because there is an x over here. There is an x over here. But on the third one, we already checked the x, right? So we neglect this one. There is a y on the first term. There is a y on the second term. Okay? And there is a y on the third term. So actually the concept is this. If there are some common terms in each of the term, you try to check it out. So actually we got 3 terms which are similar to all the first term, second term, and third term. Meaning there is a common factor 3x and y. This is 3x and y. This is 3x and y. So for the 3 terms that is given, the greatest common factor is actually the product of 3 times x times y. It is 3xy. Right? So if we will try to rewrite the given expression, it is this. The greatest common factor, which we have shown, is actually 3xy. So this is multiplied by, okay? For the first term, we got the 3xy already, right? So what we have not gotten is actually 8, right? X, y, and y. So the multiplier of the first term will now be simply 8xy squared. Those were the part of the expansion which was not checked. Okay? It is x, y, or 8x, okay, times the product y squared. So actually, the first quantity should be, the first term should be 8x y squared. For the second term, the one that was not checked is actually 6, okay, and x. So the second term inside will be 6x. Okay? For the last one, the one that was not touched is actually 3, 5. That's it. It will just be simply 3 and 5 because we touch the 3 here plus this x and y. So the last part of the term inside will be plus 15 close quantity. So this is actually the factor form of the given expression, okay, which is 24x squared y cubed, 18x squared y plus 45xy. Meaning to say, this expanded expression can be written as the greatest common factor will be 3xy. That's why it is common factor, right? The title. Times the quantity 8x squared y plus 6x plus 15. That will be our final answer. As simple as that one. So if in all your solutions you could do this, we are good. Okay, let's proceed with the next one. Factoring by grouping. I think factoring by common factors or factoring by grouping look similar. Okay? There is no form on how to bring out this one, so the best method on how to explain this one is actually by bringing out an example. Factor the given expression 4m to the third minus 2m cubed minus 6m plus 3. I think this type of expression is coming out from the SAT exams maybe. Okay? So if we try to bring out the solution, okay, we rewrite the given expression, then we will try to combine the terms like this. We will combine 4n to the fourth and 2m cubed. This is 4n to the fourth minus 2m cubed, open quantity, close quantity, plus. Okay, we'll combine minus 6m plus 3, but I will put a plus here, so the quantity inside for this negative 6m will be negative 6m, because a plus in the minus will be minus 6m, right? So this is plus open quantity, negative 6m, okay? This is still plus 3, because this is a plus in the plus, so this should be plus 3 close quantity. If we try to factor out the first term, there is a common factor 2m cubed over here, right? So 2m cubed, it seems it is same as with the common factor. There is a common factor here, 2m cubed, common factor. That's why I told you this factoring by grouping is actually look similar with the common factor. So this is 2m cubed. 2m cubed times 2 is actually 4m to the fourth, right? Because 2 times 2 will be 4, and n cubed times m will be m raised to 3 plus 1, which is m to the fourth. So this one here can be written as 2m cubed times the quantity 2m minus 1. Okay? We'll now try to factor out this one. Okay? We'll bring out negative 3 times open quantity 2m minus 1 close quantity. A minus 3 times 2m will be negative 6m, right? And a negative 3 times a negative 1 will be plus 3. So meaning to say this negative 6m plus 3 can be written as negative 3 open quantity 2m minus 1 close quantity. And if we try to inspect this term here in this, there is a common factor 2m minus 1. Okay? 2m minus 1, 2m minus 1. Common factor. That's why I told you the factoring by grouping looks similar to the factorization using common factor. So we bring out the common factor 2m minus 1 times open quantity. What remains on the first one will be 2m cubed. So this is 2m cubed. What remains on the second part will be negative 3 close quantity. So that will be our final answer. So meaning to say 4m to the fourth minus 2m cubed minus 6m plus 3 can be written as the quantity 2m minus 1 close quantity times 2m cubed minus 3 close quantity. That will be our final answer. As simple as that one, guys. Okay? You don't have to memorize this one. Just perform the operation, okay, by using your knowledge of fundamental operations, and you could do it. We don't have to memorize it. But the name of the topic for the meantime is factorization by using common factor, and this is factorization by grouping. Looks similar to the so-called factorization by using common factor. Okay, let's try to bring out number 3. Factoring differences of two squares. Okay? 2 squares. A square is square, B square is square. Okay, difference. So this should be minus. Meaning to say, under factorization, under differences of two squares, the form will be something like this, a square minus b square. And this can be written as, you have to memorize this. Okay, it will be the product of a plus b times the quantity a minus b. Because if we try to expand this one, the middle term will cancel out, and what will come out will be just be simply two terms, and they are both perfect square. That is a square minus b square. Because if we try to simplify this one, a times a will be a square, middle term is plus ab, the other one is minus ab, the last part will be plus b times minus b will be minus b square. So actually the middle term cancels if this is minus. So actually a square minus b square can be written as equal to a square minus b square. Okay, meaning to say this a square minus b square can be written as the product of two binomial, which is the quantity a plus b times a minus b. Because if we try to expand this one, what will come out is actually a square minus b square. Okay, we'll try to give you an example. I will just give you an easy one. Factor 576a square minus 169. Okay, solution. I forgot this one. Right? 576a square. I think 576 is a perfect square if you try to use your calculator or you memorize 25 square is 625, 24 is 576. So 576 is actually 24 and a square is a perfect square. It should be an a. So meaning to say if we try to expand the 24a, we raise that to the second power, it will be 576a squared. And for 169, this is a perfect square also. It's 13. So 169 is a 13 square. So meaning to say, the given term, 576 a square minus 169 looks similar to the term a square minus b square under our form. So if we try to factor out this one, okay, factor out 576 a square minus 169 is looks similar to this. That is factorization under differences of two squares. It will be the first term plus the second term, quantity, open and close quantity times the first quantity minus 13 close quantity. So this is actually an A for the given form plus B. This is A minus B. Right? But for this A here, for this problem, it is 24A. And this B here is 13. This is 24B and this is 13. So meaning to say, 570a square minus 169. By thinking this one, it will be 24a plus 13 times quantity 24a minus 13. Because if we try to expand this one, the middle term will cancel out. And what will come out will just be simply the square of the first one plus the square of the second one. But it should be negative. Okay. That's it. The last topic for this factorization part 2 will be factoring of sum and difference of two cubes. Okay, this is a little bit complicated. That is meaning to say an a cube plus b cube equal to this and a cube minus b cube is equal to this. Try to memorize this, but when we go to the so-called binomial theorem, I will give you the secret on how to memorize this one. That is, if we try to factor out this one, it will be, if this is plus, this should be a plus b, and if this is minus, this should be a minus b. For the second expression, it will be an a square, but if this is plus, this should be minus. Okay, minus ab plus b square. For the second one, if this is minus, this should be minus, okay, but the middle term should be plus. So you try to see the difference. That is a minus b times the quantity a square plus ab plus b square. I have expanded this one already myself, okay? And if we try to, what you call this, cancel it, what you call this, hold on. I have expanded this one already on my notes. That is a cube plus b cube. I multiply this one by using this derivative law. It is actually a cube plus b cube is actually a cube plus b cube. The middle terms cancel out. Even this a cube minus b cube, if you try to expand, the middle terms cancel out. So what will come out will just be simply the first term a cube. Since this is minus, this is minus also. Okay. So the expansion of this, you could memorize this one for the meantime. Except for this topic, right? This is the hardest one for this topic. That is a cube plus b cube and a cube minus b cube. Okay, let's try to bring out an easy example. Factor x cubed minus 8. So it looks similar to the form a cubed minus b cubed. So where a is equal to x and b is equal to b cubed, right? 8 is a perfect cube. So b is actually 2. Right? So if we try to factor out x cubed minus 8, okay, by following this one, it will be the first minus 2. So this is a minus b, right? Times the quantity, the square of the first one. The middle term is the product ab, right? And the last part is the square of the value of b. And the value of b is actually 2. So the so-called factor of x cubed minus 8 can be written as the product of x minus 2 times the quantity x squared plus 2x plus 4. If you try to expand this one, some middle terms will cancel out, and what will come out will be just be simply an x cubed minus 8. Okay, that's our final answer. So for those of you who are taking up college algebra, this is for you guys. If you want to subscribe to my channel is at youtube.com/@ProfDavidJ. If you want to share it, please click share. Okay, try to watch my long video format discussions. You will get something from it. Okay, I have done already differential calculus, integral calculus, differential equation, advanced math. So this is actually my 5th long video format. Actually, this is 6 because I got another long video format. Okay, this is for you guys. So watch it out. You will get something from it. Okay, this is Professor David J. De Los Reyes from Los Angeles. Good morning.